Yeah.
Great.
Cool. So for those of you joining in here, Alex is one of the earlier serverless developers who used to work at a company called Steady.com. Steady has revolutionized the way B2B messaging is being done now, and they boast investors like Stripe and all the great operators in San Francisco. Lately, Alex has been doing consulting work, and he's also authored the DynamoDBbook.com, which is like a go-to resource for serverless developers and database administrators who wants to learn about how to get into serverless databases. Without much further ado, I'll let Alex take it further, and he's going to take us through how to get started with DynamoDB and serverless applications development and how we can use them together. Over to you, Alex.
Awesome. Thank you, Prasanna. Thanks for having me. Excited to be here. Before we get too far, actually, first, let me share my screen. Oh, can you make me host so that I can share some slides?
Yes.
Well, and I'll just say a couple things. I tend to talk kind of quickly. I try to work on it, but you know, if you miss anything, just like feel free to reach, or you speak up, reach out, say something in chat. If you need me to clarify anything, happy to do that. Like, really like having questions. I'll try and stop at the end of sections to ask if people have any questions. I'll have Q&A time at the end. So really whatever works for you, I want to make sure that you're getting the most out of this. Also feel free to reach out after. I'll have some contact information, things like that. So make sure you're doing that. And now let me share. Cool. Can you all see my screen?
Yes, we can.
Cool. Sounds good. All right. So yeah, today we're going to be talking about DynamoDB in serverless. And before I talk too much about DynamoDB, I want to talk about serverless. And when you really get started there, you need to talk about AWS Lambda, which really kicked this whole thing off. Back in 2014 or so, when Werner Vogels stood on stage at reInvent and announced this new compute platform, right? And with Lambda, you have this fully managed hyper-ephemeral compute where you just load up a zip file of your code and it's going to run that code. And it's pretty amazing what it can do. But the thing about this event-driven compute is you need some sort of event to kick it off. So often people, when they get started with Lambda, they're going to reach out to something like API Gateway, where now they have an HTTP endpoint hooked up to their compute. And that's the event that's starting their compute, right? Using API Gateway, triggering this function and handling some code there. But even that is usually not enough, right? If you have this stateless compute in AWS Lambda, usually you need some sort of stateful system downstream to handle some state, right? So that might be something like S3, right? If you want to store blobs of data and store them and read them back from S3, or hold on, I think we got someone.
Is there any
can you turn mics off? No, I just heard some feedback from mics. So if everyone could mute their mic, that'd be great. Cool. Yeah. So anyway, it might be using something like SQS where, you're dropping messages into a queue to do some async processing downstream, or it might be sort of any of these sort of fan out type services or processing services like Amazon Event Bridge, which is a really cool new one, Amazon Kinesis for stream processing, SNS, kind of an old guard. But really what you're going to need probably somewhere down the line is you're going to need a database, right? And in the world of databases, you have a lot of different options. Even within AWS, you have a lot of options, right? You can choose Amazon RDS if you want to use a relational database like Postgres, MySQL, Oracle, anything like that. You can use DocumentDB if you like MongoDB. It's got MongoDB compatibility. You can use that if you're familiar with that. Or you can use DynamoDB. And that's what we're going to talk about here today, is using DynamoDB in serverless applications. And I want to cover three big things here. First, we're going to start off with why DynamoDB in serverless, because I think Dynamo has really been popular in the world of serverless and given this sort of new class of users that are using Dynamo. And we're going to talk through why that's the case. Why are people choosing Dynamo in serverless applications where they weren't before? Once we know that, say now maybe you're interested in Dynamo, we're going to go into some basics of DynamoDB data modeling, just because modeling with DynamoDB, a NoSQL database, is very different than modeling in a relational database or even in Mongo, if you've used some Mongo before. And then last thing I want to cover is just one-to-many relationships. And I think this brings it home, because at basics of data modeling, it might seem kind of weird, some of the concepts there. So then we'll walk through one-to-many relationships and see what that looks like, and maybe how you can apply it in your application. Oops. So yeah, Persona, introduced me, but yeah, I'm Alex DeBrie. I am an AWS Data Hero for my work with DynamoDB and some other databases. I wrote the DynamoDB book, so go check that out. Also created DynamoDBguide.com. That was about 3 or 4 years ago now, and that's how I really got started down this road. And just in general AWS serverless frame. I used to work for Serverless Inc., who created the serverless framework. So been in this area for a while. If you want to look more about the DynamoDB book, go check it out at dynamodbbook.com. It's really just the most comprehensive guide to data modeling with DynamoDB that's out there. So it's 450 pages, bunch of extras, videos, things like that if you want those. Talks about relationships, sorting, filtering. And it's got 5 walkthrough examples, right? So we're not just doing the basics. You can look through how to model the entire GitHub backend. We walk through that, organizations, users, pull requests, issues, repos, all that sort of stuff. So go check that out. And without further ado, let's hop in. So why DynamoDB and serverless, right? We're seeing a lot of people use Dynamo and serverless, and sort of what's the story there. So I like to break it down into 6 different factors, and we'll just walk through those. First of all, the interaction mechanics of using DynamoDB is going to feel very similar to sort of other AWS services, right? So we saw early on in this talk how you're using other services with your Lambda functions, SQS, SNS, S3, different things like that. Let's look at what that looks like. Say you're using something like SQS. If you're using Python, you might have something like this in your code. What you're going to do is import the library, the AWS client library. In Python, it's Boto3. So you'll import that. You'll create a client for your particular service that you're using, something like SQS, and then you're going to call the method on that client, right? And it's going to be that pattern within SQS. So now let's go look at S3, a different service, but also within the AWS ecosystem. Very similar pattern. You're going to import that library, create your client, call your method. Very straightforward. If you're using DynamoDB, it's going to be that same pattern, right? Here's what it looks like: import library, create client, call method. So it's not going to be, a relational database where you have to bring in some other sort of SDK that you hadn't packaged in and also handle connection pooling or maybe sort of just different things like that. It's going to be very similar, just the mechanics of using DynamoDB as any other AWS service. So it feels very natural in that way. So that's one reason. Second reason is the permissions model. So let's talk about permissions. If you're using any service in AWS, you have to mess with what are called IAM permissions. And that's how you say, hey, this Lambda function has permission to do this on, this SQS queue or DynamoDB table. So here's an example of how you might set up those permissions. This is from the serverless framework, but it's going to be similar if you're using anything else. But at the top there, I've got some SQS permissions, and I'm saying, hey, I want this Lambda function. I'm going to allow it to use this SQS send message on this particular queue. And I'm saying, okay, I can send a message to this queue. You can see that pattern there: effect, action, resource. If you look down below, we have some DynamoDB permissions. It looks the exact same, right? It's going to be the same as using other AWS services. You're going to have effect, action, resource, different things like that. So if you can write it for SQS and learn the system for SQS and S3 and SNS, all that, it's going to apply to DynamoDB as well. Another thing that's really nice about the permissions model as it associates with sort of DynamoDB and Lambda, right, is your Lambda, you'll associate a IAM role with your Lambda that has some of those permissions we just talked about. When your Lambda function spins up, you're going to get some temporary credentials injected into that Lambda function that are time scoped and scoped also to the permissions you've given it. Those permissions are automatically discovered by the AWS SDK, so you don't even really need to think about them. You just set up the permissions on your Lambda, and it's going to go. And now you don't need to worry about things like credential rotation, right? These are all time-limited credentials, so they're not going to be lasting forever. You don't need to think about rotating your credentials across your database or anything like that. So it really fits nicely just with that whole permission scheme being within the AWS ecosystem. So that's the second reason. I think another very similar reason is the provisioning model, right? And you're seeing a lot of people use infrastructure as code with serverless, and infrastructure as code preceded serverless. It existed before serverless really existed, but I think you're really seeing it take off in the serverless world. And we'll talk about that in a second. But what I mean by infrastructure as code is, you'll have your application infrastructure, all these different AWS resources you have defined in code in some way. So it's probably going to be CloudFormation. Here's a little snippet. Again, this is from the serverless framework, but going to be similar to whatever you use. You can see at the top there, I'm provisioning this SQS queue that I want to use in my application. I'm saying, hey, here's my resource, here's a type, here's some properties. And then down below, I'm provisioning a DynamoDB table. And the syntax for those, the concepts for those, very similar, going to apply elsewhere. And it's nice because you're sort of just learning one system and applying it to all these different services you're using, which are nice. So I talked about infrastructure as code, going to be very important in the serverless world. And part of that reason is because the application includes your infrastructure in a way that it didn't before, right? So if you go back, sort of pre-serverless, you have sort of larger, slower moving infrastructure, your VPCs, your security groups, and then your EC2 instances, right? And that sort of wouldn't change very much, and then you would just change the code on those EC2 instances, have auto scaling groups, different things like that. With Lambda, the infrastructure is more a part of your application now, right? You don't have all this networking maybe, but you have SQS queues rather than having like a RabbitMQ EC2 instance, right? You have S3 for your blob storage. You have these different services, Kinesis, instead of Kafka. So it's really like the infrastructure is part of your application in a way it wasn't before. And I think that's why infrastructure as code is really important here. There are a few different tools out there. Big ones are going to be CloudFormation and Terraform as sort of the raw primitives. I would say Terraform is popular in certain aspects of the world, but in the serverless world, it's really been CloudFormation that's dominated. And you see a lot of tooling built on top of CloudFormation that makes it a little easier to work with, whether that's, the serverless framework, whether that's AWS SAM, whether that's something like Begin or Arc.code, something like that. You see CloudFormation kind of being the main one in the serverless world. And the nice thing about infrastructure as code is it gives you a repeatable process for provisioning this infrastructure and things like that. So that's the third reason. Fourth reason we want to go into is the billing model. And the billing model with DynamoDB is kind of interesting. You're going to be paying for reads and writes directly rather than just sort of these abstract resources, right? So if you're working with a traditional relational database or MongoDB or anything like that, you're buying instances, which means you're buying CPU, you're buying RAM, you're buying IOPS. And it can be hard to know, like, how do my workloads and my queries, all this stuff translate into these abstract resources, right? Maybe I can get a decent estimate of how many users I'm going to have and what kind of queries they're going to run. But even then I need to translate that into, CPU and RAM and understanding where I'm going to be pegged there. And that's going to be kind of hard to do. With DynamoDB, you're actually paying for reads and writes directly. So there are read capacity units and write capacity units. And if you can say, hey, I think I'm going to have this range of users, they're going to be running these queries on items that are this big. If you can do that calculation, you can know exactly how many RCUs and WCs you're going to need rather than sort of having to figure out how that converts into CPU, RAM, different things like that. So that's really interesting. Even more interesting is they now, in the last couple of years, added different billing models, right? So the old model was sort of a provision capacity model where you say how many RCUs and how many WCUs you want, and they'll provision that for you. And if you exceed it, you'll get throttled. Now they have an on-demand pay-per-use one where it's just like every single request comes in, they'll just say, hey, this is how big it was. This is how many RCUs or WCUs you used, and we'll charge you for that at the end of the month. And it's more like Lambda, right, where you're paying for your compute time, or it's more like S3 where you're paying for requests and storage, or SQS where you're paying for messages. It's very much in that pay-per-use world that a lot of people like with serverless, which is nice. Next factor I want to talk about is just like how it helps you in your development environment using DynamoDB in your application, right? And one thing that's nice about serverless, you have infrastructure as code, you have these pay-per-use resources. It makes it very easy, for us to have our production stack. But then me as a developer, I can spin up the entire stack locally, and it's going to be pretty quick. It's going to be like almost an exact replica of what that production stack looks like. And it's also going to be cheap, right? And if I'm paying per use on DynamoDB and I have a dev environment, I'm doing, not very many requests against that. It's going to be cheap. It's not going to cost a lot. So if you have these pay-per-use infrastructure as code friendly and quick spin up resources in your stack, you can basically just replicate your stack for each developer on your team, and they can get better confidence about sort of what they're running against, which is really nice and I think underrated about DynamoDB. And then last factor I want to talk about is just the scaling characteristics of Dynamo, where if you have this Lambda compute and all these serverless services that sort of auto scale up and down, how does Dynamo sort of fit into that world? And I like to demonstrate this with a chart here. So I got a chart on the bottom, the x-axis there. We talk about data size, right? And you can think about your database getting bigger and bigger over time, 1 gig, then 10 gig, then 100 gig, you hit scale, you get terabytes, So as you go further out on that x-axis, your database is growing. On the left side, we have performance, right? And sort of as you go higher on that x-axis, you can think of that as response time. As you go higher, it gets slower, right? So it's blazing fast at the bottom, then just fast and sluggish, painful. If you're working with something like a relational database or even Mongo in certain situations, you might have a performance curve like this that slopes up over time. So, you're running locally or you just deploy it the first time, you're super happy with it. It's going blazing fast and everything looks great. You get down the road, you have more users, more access patterns, things like that. And it's starting to get sluggish, right? And now you have to investigate. You have to dedicate some of your sprint time to figure out, hey, what's going wrong with my database? Do I need to add a new index? Do I need to do some different things, maybe denormalize a little bit? And then at some point, you might get to that painful spot where you've done all the optimizations you can. And hey, we really need to re-architect, migrate, do some different things to alleviate this load on your database. So there's sort of this long-term drag on your data model, and it's hard to know how that's going to evolve over time. If you contrast that with Dynamo, the performance curve is more like this, right? It's going to be just consistently fast over time, and it's going to perform the same in your test environment with a gig of data as it does in production with a terabyte or 10 terabytes and all that. And you have that confidence that it's going to scale consistently, and you're not going to have this long-term drag. You can go work on other features without having to come back and babysit it all the time. So, those are the reasons why I think people are loving DynamoDB and serverless. Let's get into, I guess, first of all, any questions on that? I'm not seeing any chat, but anyone want to speak up? Any questions on that?
I have a quick question on the scalability. Let's say the Lambdas have got auto-scaling groups, and the same way DynamoDB also has got that. But we also know that Lambdas also got issues like the cold start or the timeout errors and stuff like that. So are there any kind of issues that are there with DynamoDB, like when a request comes, it will automatically get honored, or is there any issue that might come up?
I mean, so the cold start issue with Lambda, that's going to be sort of regardless of any sort of database you can do. And I would say that those cold starts have gotten quite a bit better. There's also some additional features you can use of Lambda where cold starts are sort of less of an issue they used to be. And it's generally like a pretty, it's going to be on the long tail issue and usually not too bad. So I would say, I think that's become less of a factor than it has been in the last couple of years, unless you're using something like Java or C#, that can still be kind of slow to boot up that JVM or something like that. So it can depend, but also that's going to be database agnostic there. So whether you're using Dynamo or relational database, you're going to have that sort of startup time. As for the second one on timeouts, I'd say like sort of any AWS service, if I'm using a service, I occasionally have connection timeouts. These are just working over HTTP, different things like that. I usually just set up in my client like pretty aggressive timeouts. If it doesn't connect within the first second, it's usually not going to connect. So then I'll just cut it off and then reissue that command, something like that. So I just advocate having that. One other factor I didn't consider or didn't mention is often these relational databases have connection limits where you can only have so many open connections to your relational database, 100 or 1,000 or whatever that is. And if you have all this ephemeral Lambda compute sort of spinning up all over the place, it's easy to exceed those limits. And that's where you'll actually get, blocked from spinning this up saying, hey, we have too many open connections. You can't do that. Try again. So that's another, factor to consider too with your database choice.
Understood. Okay.
Cool. Good question. Sweet. So let's go into basics of data modeling. I like to start off with just some vocabulary, and I think the four key terms that you really need to know are going to be table, item, primary key, and attribute. And let's just walk through this with an example. So here I have some data. It includes, some users in an application. So I have myself and then a few folks from Amazon, Jeff Bezos, Jeff Barr, Werner Vogels. If you look at all this data together, that's going to be called a table. All the collection, all the items, or all the records in that are going to be a table. Similar to a table in a relational database, but with some differences as well. Similar to a collection in MongoDB. If you could look at an individual record in DynamoDB, that's going to be called an item. So I've outlined in red there, Alex DeBrie, all that data together is going to be called an item, similar to a row in a relational database or a document in MongoDB. Now, when you create a table in DynamoDB, you need to specify what's called a primary key. And that primary key has to be included on every item that you write to your table, and it's going to uniquely identify that item. So you can't have two items with the same primary key. In this case, what we're using is a username for that primary key. So you can see that highlighted on the right there. Every user that comes in, they need to have that username, and it needs to uniquely identify each item. So you can't have two user items with the same username. In addition to that primary key, you can have other attributes, which you can consider sort of similar to columns in a relational database, with the big difference that you don't need to specify these up front, right? So DynamoDB is schemaless, which means you don't have to sort of declare your schema. You can just sort of throw blobs of data in there and get it back as long as it has that primary key. This doesn't mean you shouldn't have a schema. You should absolutely have a schema, or you're going to have trouble down the line, but you're going to enforce that schema in your application code rather than at the database layer, right? So the database layer is not going to do a lot for you outside of that primary key. So you can see here, I have first name, last name, email. You can also use complex attributes, things like lists or maps or sets, different things like that to model data as well. So we talked a little bit about primary key. Let's go into more detail on that, because primary key is going to be very important when you're using DynamoDB. And there are two types of primary key. There's a simple primary key, which has just a partition key, and then a composite primary key, which has a partition key and a sort key. So let's walk through that here. You know, the example we already showed, that was a simple primary key. It had just a partition key, that username that uniquely identified each item. We can modify our table a little bit and make it a composite primary key, right? And I've outlined it in red there. That primary key now has two parts. It has an employer part, which is the partition key, and it has a username part, which is the sort key. So you can see there, you know, my employer is DeBrie LLC. The other folks all work for Amazon. The interesting part there, if you look at what I've highlighted in red, like lots of different employers, lots of different users in this case have the same employer, right? Amazon Inc. That's okay. It's still unique because it's the combination of those two primary key elements that need to be unique. So even though that employer is the same for some of them, that sort key is different. So that's fine. That totally, that works. And that's going to uniquely identify each item in that table. As we get deeper into this data modeling, I want to talk about what I call DynamoDB's guiding principle. And this affects every sort of feature and the way they think about it, right? And this isn't in their documentation or marketing material in any way, but I think they basically, what they're saying is we do not want to allow operations that aren't going to scale well, right? And if we talked about this chart earlier, how there's that performance curve that slopes up for a lot of databases, and DynamoDB has this very flat performance curve that no matter how much data you have, it should still perform the same on day one as it does on day 1,000. So how do they do that? Well, a couple different things. First of all, primary keys are going to be very important. And that's why I talked about them a little bit in depth before. But that primary key, you know, if we go back to this one that has that composite primary key, it's very easy for me to query my table based on that primary key. And that's how I'm going to access my data, is based on that primary key. So it's very easy for me to say, hey, go get that item, you know, Alex DeBrie and DeBrie LLC, bring back that item so I can look at it. Or it's also very easy to say, hey, give me all the users that work for Amazon Inc., right? It would go over very efficiently, find those and send them back to me. However, it's not as efficient at querying on those other attributes, right? So it'd be very difficult, as this table is set up, for me to say, hey, give me everyone with the last name Bar, or everyone with this particular email address. This table's not set up to do that. It's got to be based on that primary key. The other thing I'd say is there's no join operation. I think this throws people for a loop when they come to NoSQL for the first time, because they're used to normalizing their data, joining it at runtime. So let's understand why there's not a join operation, why that primary key is so important, with just understanding sort of how DynamoDB works under the hood. So far we've sort of been thinking about, at least I used to think about Dynamo as like this giant, super fast machine in the cloud, but Amazon doesn't have any better computers than anyone else. They just sort of have structured it in a great way. So when we're actually talking about DynamoDB, it's not just this giant computer, but actually your data is going to be split across all these different computers, right? And these are called partitions, right? So there's all this different partition of data. You know, for about every 10 gig you get in your table, they're going to give you another partition. You don't need to know about the partitions per se in your table, but I just think it helps to understand the data modeling and some of the principles behind it. So let's assume I have a table with, you know, 15, 20 gig of data. So I have two different partitions here, partition 1, partition 2. When a request comes in, let's say we're doing that put item request and we're saying, hey, I want to add this new item to my table, right? Andy Jassy is also a user at Amazon. Let's put him into our table. The first thing that's going to happen is that DynamoDB front end, which is called a request router, it's going to hash that partition key value. So our partition key in this case was employer, that first half of the primary key. It's going to hash that value and then figure out which partition it belongs to. So in this case, you know, it belongs to partition 1. It's going to go out to partition 1, write that item, and then return back to you, say, hey, we were able to write this successfully. Now, the great thing about this is you can easily scale up the number of partitions, right? So if I go up to, you know, 25 gigs of data, I get a third partition, or I can add 6 more partitions, or I can add 1,000 more partitions. The really nice thing is that initial step is going to be an O1 operation that's going to basically be the same time no matter if there's 2 partitions or 1,000 partitions, right? When they hash that partition key and figure out which partition it belongs to, that's an O1 operation. That's a lookup in a hash map. Go figure that out. And then they're messing around with a partition which only has 10 gigs of data. It's going to be organized according to a sort key, which is a B tree, another very fast operation, especially when you're talking about 10 gigs. So that's how they get that nice, efficient scaling properties, by being able to scale these out across these partitions. So those are 2 factors that are really important when you're moving from SQL to NoSQL, right? Importance of primary keys, no join operation. What are some implications of this, especially for how we model our data in DynamoDB? So one thing is the importance of what are called secondary indexes. And let's go back to this slide where I was talking about before. We can query with those primary key attributes, but we can't query with those other attributes. But often you need to query by both, right? You might have one where you want to get all the employees by the employer, but also, get a particular employee by, let's say, the email address, right? Where I want to go out and get someone by their email address. What you can do is set up what's called a secondary index on your table and say, in this case, hey, I want to index that email attribute. And it's basically when you write an item into your table, it's going to also replicate that item into your secondary index in a different shape, right? So we look at my secondary index here. This is all the same data, but basically it has you can think of it as a new primary key that then you can access by, you can query by email. It's nice and efficient that way. So secondary index is very huge. The important part here is data from your base table is going to get copied into that secondary index with a new primary key, which enables additional access patterns. One thing you need to know about secondary indexes, you can use query or scan. So you can use read operations with it on your secondary index, but you can't do writes directly on your secondary index. All your writes need to go through that base table, and then it's going to get replicated out into that secondary index asynchronously. So that's one major implication. Another major implication of sort of most NoSQL databases is you need to know your access patterns in advance. And this is going to be different, if you're coming from a relational database where first you think, how do I normalize my data, put it in a nice normalized fashion? I set up all my tables and the links between those tables. And then after that, then I go and write my queries, how I'm going to access my data. With Dynamo, it's sort of reversed. You think, how do I access my data first? And then I'm going to lay out my data so that it handles those access patterns, right? So that it has the right primary keys and secondary indexes to handle those access patterns. So it's a little bit flipped in terms of how you approach modeling in DynamoDB. And then third, now we're getting into the wild stuff where it really starts to throw people. But often you'll put all items into a single table and use these generic attributes for your primary key. So if you've heard about single table design in DynamoDB, this is a little bit of what that looks like. I want to walk through it with an example so I don't throw you. So the examples we've shown so far weren't sort of following this pattern, but I think this is what you'll see more often if you're working with Dynamo. So let's do an example. Maybe you're building a SaaS application, right? And you have 2 different types of entities in your application. You have organizations, that's who signs up for your SaaS applications and pays the bills, different things like that. And then you have users that belong to those organizations. So maybe I'm an organization, I buy 5 seats and I sign up 5 users for this application. So let's start by modeling organizations into our table. So we have a table here. We have 2 different items. We have Berkshire Hathaway and Facebook. You can see those outlined. 2 things I want to cover here. Number 1, look at the primary key and especially the names of the primary key attributes. We're using very generic names for these. So rather than it being sort of organization name or username or anything like that, we're using PK for partition key, PK partition key, and SK for short key, SK sort key. And the reason we're doing that, again, is we're going to have multiple different types of entities in here. So not all entities are going to have the same attributes, right? A user might not have an organization name, an organization is not going to have a username, different things like that. So we need to use more generic values there. You can also see if you look at the values for these primary keys, notice how they're kind of funky. We're combining a couple different values here, right? So we have a prefix, we have ORG hash to indicate this is an organization and then Berkshire, right? So we're using maybe these prefixes or different patterns, like jamming multiple values together to create that partition key. So that's how we get started. We've got 2 organizations in here. Let's add a few users to this table. So same table here, still got that PK, SK pattern, still have those 2 organizations in there, but now we've added these 3 users. We've got Charlie Munger and Warren Buffett working for Berkshire. We also have Sheryl Sandberg working for Facebook. So notice that the sort key pattern is different here for users than it is for organizations, right? And then instead of having that ORG pattern, we have user hash pattern. one thing that's important when you're working with DynamoDB is this concept of an item collection. And an item collection refers to all the items that share the same partition key in your table. So you see I've outlined here in red, there are 3 items that share this partition key of org hash Berkshire. And the reason item collections are important, remember how this is set up, where that partition key is really important because it determines which partition you go to. It makes it a very efficient operation there. So in this case, it'd be very efficient for me to go hit that entire item collection for Berkshire, use the PK of org hash Berkshire. It's going to, all these items are located on partition 3, and it's going to go get those very quickly. Another thing you'll notice there is I have different types of items in that item collection, right? So at the top, I have that organization item outlined in blue, but then below that in green, I have these user items. We're gonna talk about that as a pattern in the next section. But so start getting used to some of this stuff because it can be kind of interesting. Last thing I want to say in terms of implications is just get comfortable with denormalization, which I think this is the hardest part for a lot of people. Come from that relational world where they've learned normalization, first normal form, second normal form, third normal form, but get used to some denormalization. You might repeat yourself. You might have complex attributes, just different things like that. We're going to see this in the one-to-many section that we're going to go to in a second, but you need to get comfortable with that. So next section is about one-to-many relationships. Do we have any questions about sort of the basics, the terminology, those concepts, implications, anything like that?
I think we are good to go.
2 more minutes.
I hear something. Cool. And again, feel free to just drop it in the chat if you want to do that as well. We can do that. So, but I'll keep going with one-to-many relationships. So let's talk about how you model one-to-many relationships in DynamoDB. First of all, what am I talking about with one-to-many relationships? What is one-to-many? It's when you have some sort of parent entity that has related child entities, right? So it might be an office has multiple employees working for it. Maybe I have lots of different office buildings, but each employee only works for one office, right? So one office has many employees only work for one office. Could be customer and order. So if you're talking about a retail application, right? I, as a customer, hopefully I keep coming back and making multiple orders on your platform, but each order is going to belong to one customer. Or the example we already looked at, right? Where we have a SaaS application, organizations sign up and users belong to that organization and make actions on behalf of that organization. So when you're working with a relational database, there's generally one way you handle one-to-many relationships, right? And that's going to be a foreign key relationship. You do that when you do your DDL and sort of create your data model, and then you join at read time to sort of join these 2 different entities together if you need to do something like that. But if you're talking about DynamoDB, there are actually 5 different strategies you can use, and really more if you can invent them. But these are the 5 I go through in the book. So let's get started. The first 2 are both going to be about denormalization, and let's start with denormalization and a complex attribute. So let's go back to our example we already had before, right? Organizations and users. This is a SaaS application. Good question, Kieran. I'll come back to that one at the end because it's a little off, but yeah, great question. Thanks for queuing that up. Anyway, let's start with this one. We have organizations, we have users. That's a one-to-many relationship. Let's say we have another one-to-many relationship for payment methods or something like that, right? Where an organization, they sign up, they need to find some way to pay, and we allow them to set up multiple payment methods. Maybe it's like a bank account or a fallback credit card or something like that. But just in case one doesn't work, they can build a second one. So that's another one-to-many relationship we're going to have here. And I'll show you how we're going to model it in this situation and why we're going to do it that way. So moving out here, what I've done, I've outlined in red there, I've added this attribute called payment method. And if you look at the details of that, it's going to be a map, right? So it's going to be this complex attribute where I'm storing multiple different types of items in there, right? So I have a credit card, I have a bank account, different things like that. And you wouldn't normally do this in a relational database because in a relational database, if you're normalizing, you don't want to have complex attributes. You want to have like a scalar value in your as your column value. Otherwise, you'll sort of split it out as another table, join it together, different things like that. So you wouldn't do this in a relational database, but you might do this here in DynamoDB. And when is this a good fit, right? It's a good fit when you don't have any access patterns on the related item directly. So in this particular situation, right, the payment methods are the related item, but we're never going to have an access pattern when we're saying, hey, I have this credit card number. Can you go find which organization it belongs to? We're never going to have that situation. Our situation here is going to be being able to show people for a particular organization what payment methods they have, or at the end of the month, going through our organizations, pulling out Berkshire, saying, okay, I have the Berkshire item. What are its payment methods? Charge that one. If it doesn't work, charge the second one, things like that. So it's always within the context of an organization. So I don't need to access it directly. Also, it's good if you have a limited number of related items, right? And this is because a DynamoDB item has a limit of 400 kilobytes per item. So you can't exceed that. If you tried to exceed that, it'd be too large. And in this situation, we're not going to allow people to sign up with 4,000 payment methods. So it's okay to just store a little bit of extra data on that particular item. But you wouldn't want to do this in a case where the related items are essentially unbounded, right? If you think about Amazon, and we talked about customers and orders being a one-to-many relationship, you wouldn't want to store orders directly on a customer because, I mean, we go to Amazon all the time and are always buying this stuff. And at some point, you'd probably exceed that 400 kilobyte limit on a customer if you just allowed them to sign up as many items as they want or orders as they wanted on that particular item. You'd run out of space. So it's good here where you can have a limit on the number of related items. So that's the first strategy. That's a denormalization strategy. Let's look at another denormalization strategy. And this is denormalization and duplication, right? And so let's look at what we have here. Here we have maybe like a bookstore or a library, something like that. And one author has multiple books, right? There's a one-to-many relationship because an author might write multiple books. So here we have, Stephen King, he wrote It and The Shining. We also have J.K. Rowling that wrote Harry Potter and the Sorcerer's Stone. If you look at these, some of those attributes, you can see that we've duplicated some data about the author, so about that parent, onto these sort of child items, right? These are books, and we've just duplicated some information about that parent, like the author birth date, onto that child item, that book, rather than sort of joining those together after the fact to, get you get the book, you also get the author, things like that, and enrich that. We're just duplicating that data on there. So you wouldn't do this in a relational database, but you could do that in DynamoDB. When is this denormalization and duplication a good plan? This is good when that duplicated data is immutable, right? Because now, say that data does change. Now you have to go out and find all those different places where it was and change it, and that can be a hassle. If you're talking about something like an author birthday, right? Stephen King's birthday is the same yesterday as it is today as it's going to be tomorrow. I'm never going to have to change that. So it's okay to duplicate some of that data without having to worry about sort of data inconsistency down the line. So that's really nice. We can do that. Even if it's not immutable, you can also do it if that data doesn't change very much, or if it's not replicated that much, right? So situation there is, maybe if it's only replicated across one or two items, it's fine to find those items, and it only changes, maybe at most once a year. Hey, not a big deal if you have to duplicate that and then go find it and incur a little higher write cost when that does change. So that's when that's a good situation. So those are two denormalization strategies. Let's move into a third strategy. This is composite primary key and the query. And again, let's go back to that SaaS application we had before. And we talked about that item collection, right? And imagine you have an access pattern where you want to get all the users for an organization, but you also need some information about that organization itself. Maybe the organization name or the subscription plan or something like that that's only on that top level item. That would normally require a join in a relational database, but what you can do here is just handle it all in one request, because you've sort of pre-joined these items by putting the organization item and then the user items right below it. You can get all those items in a single request, which is a nice, efficient request. So basically, you've pre-joined that data rather than doing a join at the database layer, which you can't do in a relational or in a NoSQL database like Dynamo. So this is going to be a pretty common pattern to sort of pre-join those items together. Fourth pattern here is around secondary index and query. So this is going to be very similar to that last one. So let's just look at what we have here. And I see the questions queuing up. These are all great. I'll get to these at the end. Just to avoid breaking the flow here. But let's go back to this SaaS example, right? And imagine, we have our organizations, we have our users. Let's imagine we have some other related entity from those users, maybe like tickets, right? So tickets belong to each user, can have multiple tickets. There's a one-to-many relationship between a user and tickets. What you might think here is just sort of jam those tickets in right below those users, right? And so here, Charlie Munger, I've added a few tickets there in red. And now those are all nicely near each other. I have this item collection. I can efficiently get down to Charlie Munger and his tickets, right? So I have that user item and those ticket items are all right near each other. But one thing we want to think about is remember our previous access pattern. We have that access pattern where we want to get an organization and all the users in that organization. If we go look at our table now, now that original item collection is sort of all jumbled up, right? Where we have the organization, we have the user, but then we have a bunch of ticket items between. Then we have another user and a bunch of ticket items. So our original access pattern of getting all the users plus that organization item, we're going to be filtering through a bunch of tickets and other garbage in there that we don't want to get. So we're not going to do it that way. We're going to do it a different way. We're going to pull in a secondary index here. So what we have is in my base table, I've added my tickets down here. They're in their own sort of item collection, have their own partition keys, things like that. But I've also added these GSI1 and PK and GSI1 SK values. So these are going to be global secondary index. I'm adding a global secondary index to my table. And I'm using that same PK SK pattern here and adding these values to them. One thing you can look at is if you look at that Charlie Munger user item and his ticket items, they have the same PK. So that GSI1 PK is going to be the same for Charlie Munger, the user, and for all his tickets. Now, if we go look at our secondary index, now we've sort of reshuffled our data in a different way. You can see here, I have this item collection that's very efficient. It has Charlie Munger's user item. It has these different ticket items. They're all right next to each other, so I can get that very efficiently. And it's a nice, efficient request while still maintaining the efficiency of my my first access pattern, right? That organization and users. So that secondary index and query, it's very similar to the third one, but it's good when that primary key is already being used for something else. So you can enable that additional access pattern. All right, last strategy we're going to cover, and then we'll go into some questions, is composite sort key. I don't see this one a ton, but it is kind of an interesting one to see and allow you to get creative as well. So imagine you have a situation where you have you're working for some sort of franchise that has a lot of stores all over the world, right? And you have different access patterns on each stores. Get all the stores by country, or get all the stores in a particular state in the country, or a city, or a zip code, things like that. You can enable this here. So what we have here, imagine I need to get all the stores in a particular country. I can use that partition key to get all the stores in the USA very easily. But then I say, hey, I need something more specific than that. I need all the stores that are in the state of New York. What I can do is just do as part of my query, I can do an expression that says, hey, begins with NY. It's going to very efficiently go to that using a B tree and find those 3 stores there. Now maybe I need to get even more specific, and I need to get down to a particular city. And I say, hey, not just New York, but actually New York City itself. And I can do that right there. It's all built into that sort key. Or maybe a particular zip code in New York City, and I can get down to the specifics there. So the nice thing about this composite sort key is I'm putting a bunch of different values into that sort key that allows me to search at different levels. So this is good when you have lots of different levels of hierarchy, right? We have more than one. We have country, state, city, zip, right? We can get lots of different levels. And also when searching at a particular level in the hierarchy, you want all the sub items, right? So if I'm searching for a particular state, that means I want all the ones in that city and zip code as well. I didn't have that particular problem when I talked about organizations and users and tickets, right? Because if I want to get organizations and users, I don't want those tickets. So that's why that didn't work with this pattern as well. So those are the 5 strategies. Again, just a summary of what we covered today. We started off with why people are using DynamoDB and Serverless. And this is sort of aside from the data model, what are those factors about DynamoDB that make it a good fit for serverless applications? And then once we think, hey, maybe we're interested, it sounds like a good fit for serverless applications, let's talk about the basics of DynamoDB data modeling, right? Because NoSQL is different than SQL. So you need to learn some new patterns there. Get the foundations of why it's different. And then we talked about one-to-many relationships just to bring it home a little bit and say, hey, what are these different strategies we can use to check that stuff out? So now we'll do questions. So I'll scroll back to the top and start with Kieran's, but also feel free to drop additional questions in here. And if I start to answer your question and I'm not getting it, feel free to hop in as well. So Kieran, in Lambda, we need to provision RAM memory. In DynamoDB, do we need to provision? If so, where do we start when we don't know to what extent the database scales? So great question. And that goes back to what we were talking about with the billing pattern, if you were here, or the billing model at the beginning. I'm going to scroll back through this stuff. But basically with Dynamo, right, there are first of all, there's 2 different billing modes, right? So you can do provision capacity, which says, hey, I want this many read capacity units and write capacity units, and all your stuff needs to fit within that. And if you don't provision enough, you'll get throttled. Or you can do on demand, which says basically just make sure all my queries succeed and bill me for them later. And that on demand is a little more expensive if you can get good utilization out of your provision tables. But actually, I see so many people that aren't getting good utilization out of their provision tables that on demand actually saves them money and is a lot lower maintenance as well. So And one other thing you can do is you can flip your table between on-demand mode and provision capacity mode. So, like you're saying, where do we start if we don't sort of know how much usage we're going to have? We'll start off with on-demand mode and maybe run it that way for 2 or 3 months, get a sense of where your sort of usage is. And if you have predictable usage, then you can go back and say, okay, my read never exceeds this. You set it at whatever the max is plus 10%. My writes never exceed this, same thing. And now you're getting provision capacity and you can flip back and forth as needed. So it's a good question there. Glenn has a question. What happens to performance when the hashes of an item collection grow beyond one partition? So that's a good question, right? So I mentioned partitions are mostly invisible to you. Dynamo says that they're about 10 gigs, but you don't have a good sense of how those partitions work. So Glenn is saying, what happens if I have so many items that have the same partition key that my item collection is now split across those 2 different partitions? A couple of things to note there. As I understand it, again, not sort of public, but just based on talking with different people on the Dynamo team, I believe it's, if you make a query that's going to hit just one partition, that sort of front end aspect where we're talking about right here, it's able to know sort of the range of sort keys that are going to be on any particular partition. So if you're getting a single item, it's going to be the same whether that item collection is split across 2 or not. Now, if you're doing a query operation where you're getting multiple items at once and maybe it hits the end of one partition and now needs to skip over to the second partition, that could be a little extra performance hit there. But again, that's going to be pretty rare, right? To have a query where, a query can only return 1 meg max. And if you're talking about 10 gigs on a partition, like the chances that you'll actually hit that sort of boundary very often are going to be pretty rare. But other than that, you shouldn't see much performance impact beyond that. So good question. Add on to Kieran, another question on that provisioning stuff. Is the provisioning at a table level or a database level? So with Dynamo, the table basically is the database. Like each table is totally separate from each other table, right? So you'll provision for a table itself. And so don't think of it like a relational database that has multiple tables within it, that you're provisioning sort of one big thing that has a lot of different things. Now, each table is sort of independent. The one thing I would say is you do need to provision for your secondary indexes as well. So you'll have your base table. And then if you have 3 global secondary indexes, each of those will need either provision capacity or on-demand capacity as you sort of set up on your table. Manish, hey. You nailed all this. You responded to Quran with better answers than I did. So thanks for doing that. I should have just pointed to you at the beginning. Hussam, what is the interest of duplication in this case? Avoiding to do a second queries in the author table to gain access time. Absolutely. So let's go back to, he's talking about when we did some denormalization and duplication, right? So imagine you have an access pattern. I'd say the big problem with a one-to-many relationship that you're trying to handle often is like, hey, when I'm fetching that child item, how do I also get information about that parent item here, right? So if I'm fetching an item about a book, I might also want to have some information about the author that's available here. And there are 2 ways you can do it. One would be, because we can't make a join in Dynamo, you could go get that book first. Then when you pull that book back and then you say, okay, here's the author, go get the author item as well and show all that author information. But now that's 2 requests. They might be also sequential requests are going to be less efficient. Whereas if you have it set up this way, you can duplicate that information about the author onto the book. You can save yourself that duplicate request time rather than sort of doing in application joins. So that's the big point there. Let me know if that makes sense and we can cover that more. Austin, will it be recording? Yes, there will. Jonathan, how would you manage updating millions of rows in Dynamo every day? Would you implement some sort of fan-out strategy and have multiple lambdas do the update items? Jonathan, are you still there? And can you tell me a little bit more about like what you're updating? Are these like known items that you're updating or like, is it, I guess, can you tell me more about, like, is it like on a cron every day at, 1 a.m. you want to start updating all these items, or what's that sort of look like?
Yep. So in this case, it would be you have restaurants, and each restaurant sells a particular set of items, and those items have prices associated with them. Now, all the restaurants are the same brand, but the items that are at different restaurants, they may be the same, but they have different prices, just depending on where you are in the world. So what we want to do is we want to update the prices for those items for that particular store every day, because the owners of the stores choose the prices basically the next day. They can change them whenever they want.
Gotcha.
So
So they might come in and say, okay, today Big Macs are like $2.50 or some
Yeah.
number times like a thing, and now you need to go update 10,000 McDonald's or something like that.
it would be more like let's say store 1, 2, and 3 decide to update one of their items from $2 to $3, and you would just want to update those 3 stores and those items. But
Gotcha.
potentially you have a lot of items, so it would just be a lot of writes.
Yep. Yeah. Yeah. It's hard to know for sure. I mean, if it's something where they're coming in and saying, okay, update items or stores 1, 2, and 3, that might be something you would do just as the request comes in, because now it's like sort of individualized, right? They're saying update this. If it is true, like a true bulk operation where they're saying, okay, now I need I can do a request that basically says I need to update 10,000 things that are hard. Now you probably need to queue that up like in SQS or something like that as that happens, and just sort of churn through those. And then depending on sort of what sort of consistency or view you want on that, maybe instead of SQS, you might use like step functions or something like that, right? Maybe you put all the updates you want to do in like an S3 file or some sort, and maybe if you can fit it in the SQS or the step function input, you could do that and then just farm it out across those maps. So you have some visibility into that. So I'd say that'd be a quick glance. If you want to talk more about like specifics on that, feel free to email me after and we can chat on that as well. But yeah, that's cool. That's a cool pattern.
Okay.
Kieran, what are the most common issues with DynamoDB that needs to be monitored, observed to make sure there are no issues? Yeah, good question. I would say a couple ones. Like number one, you want to see how much you're getting throttled, because throttled, like, you know, if you're using provision capacity, that could indicate you don't have enough capacity, and then the writes are bouncing back at you. So throttling is going to be a big one there. I would also just check at I would check if you're doing any scans, so you can see scan performance. You generally shouldn't be doing scans except for very limited situations, and you know what you're doing at that point. So if you don't have a good sense of what you're doing and you see any scans happening, I would question that. I would say if you have very high, if sort of your RCUs or WCs are like way out of whack for each other, right? If you have way more reads than writes or way more writes than reads, that could be something to investigate. And it doesn't necessarily mean that it's wrong, but it's something that I would look at and say, okay, am I doing this efficiently, right? Am I doing too much? So like on sort of the read aspect there, if you're reading way more, you might not have a very targeted query. Maybe you could use a more targeted query, better primary key setup or index setup so you're not sort of reading and just dumping a bunch of items, things like that. So that would be a couple things to look out for. If you're using DynamoDB transactions, I would also look at just like transaction conflict errors, which could indicate contention on particular items, and maybe a transaction is not the best use case for that. So, but those would be the big things I would think about there. Manish, how to model many-to-many relationship in DynamoDB? That's a great question. I cover 4 of the different strategies in the book if you want to check that out. There are a couple different patterns, and also the DynamoDB docs have a little bit on these as well. But you might use some duplication patterns like we talked about with one-to-many. You might use something called an adjacency list, which allows you to sort of reshape it and maybe look at it from 2 different angles. Sometimes you also just might need to make 2 requests, which we talk like is what we're trying to avoid in this particular situation. But with many to many, especially, sometimes you might need to make multiple sequential requests just because of the nature of how that is, especially if, you know, duplication is not going to work for you because maybe that information is replicated across a lot of things or is going to be updating frequently. So it depends on your situation, but those would be the main patterns there.
Thanks, Alex. So I'll just point out why a specific use case that I have been struggling with it for a long time now. So it's an IoT platform, and each account has multiple devices and multiple users. So what happened, like we use security groups to make sure that a specific user has access to only specific devices. So what happens? So when a user logs in, so the first request goes to the backend. It basically checks which security group this user belongs to. And then in the second query, we find out which are the devices which belongs to this security group that user belongs to. So this makes up 2 queries. So I've been looking for, a pattern where, and we use a single table. So I'm looking for a pattern where, I can get it in a single query if that is possible.
Yep. And that's going to be a tough one. And very often with sort of like permissions, things like that, you might need to make the two queries. I'd say the thing I would look out for there is like, can I duplicate that in some ways, right? So does, like, depending on how often those things change, would it make sense, and also how many of them there are, would it make sense to duplicate the devices onto the user, right? Like if a user has one security group and each security group has like 10 devices, could I just duplicate that onto the user? So then when I fetch the user, it has the security group they're in, but also the devices in that security group. That could be one way, or sort of the opposite one, right? If they're making requests about a specific security group, can you look up the security group and it already has sort of cached on it, right? The users that can access that. And so that's probably going to be your best bet if it works out. And if there's so much churn or there's so many items where you can't do that, then it's sort of like you're going to have to make two requests. And it's not the end of the world. You just try to avoid that where you can, and depending on your needs as well.
Yeah, thanks. It makes sense. Thanks a lot.
Yep. Yeah, sure thing. Great question. Patrick, any horror stories on unplanned access patterns or multi-table designs? I think you can go out there and just see blog posts of people saying why Dynamo sucks or something like that. And almost every time it's because they didn't think about their access patterns up front, or they're doing sort of this multi-table design with like lots of chained sequential requests, or they're putting everything in one partition. So I think it's like you can see those, and almost all those are going to be about that. I think with Dynamo, and really with any database, you just have to understand the trade-offs you're making, right? And there are trade-offs across all different databases. And with Dynamo, you need to be more prescriptive up front. You need to learn these different access patterns, which are weird and feel kind of weird. And then also it can be difficult to add new access patterns down the line. I think it's not as bad as people say, but it is like more involved than just like adding an index to a relational database or something like that. So, but understand like what you're getting with Dynamo, right? You're getting that super flat performance curve. You're getting a fully managed database where you don't have to do anything. Like it's RDS and relational database management services like that like work really well, but there's still like some aspect of maintenance you need to do around upgrades or backups or things like that. But Dynamo is like completely managed. You tweak two knobs, RCUs and WCs, or you just flip it to on demand, and you get all that stuff. Works well with serverless. So like if that's the set of trade-offs you want, or like benefits you want, then there are like these trade-offs on the other side, and you have to learn how to work around those. But definitely like people get frustrated with those trade-offs and don't want to do it. And I don't blame them for it. Like I'm all in on Dynamo, but like I can understand people that have the other side. So that'd be the big one. But good question. Prasanna, aside from the fact that DynamoDB is NoSQL and Aurora is MySQL, any other parameters where one is better than the other? I basically just covered that. So I should have read yours with it, but they're just different trade-offs among those. And it's sort of, you need to understand like what are the scale constraints you're going to be running up against? What are the compute environments you're going to be running up against, right? Like running in Kubernetes or EC2, I think opens up relational databases more than sort of running in Lambda. You're just going to have some issues when you're running in Lambda if you're using a relational database. And, maybe you're willing to sort of bite off those issues, or you think they won't affect you. And that's totally fine too. Like I would think about your sort of compute model, but then also your scaling needs and just your familiarity. Lots of different factors to think about there. So, Kieran, can Dynamo handle time series data? Yes, it can. People use it for time series. The one thing I would say is like Dynamo will not let you do aggregations, right? So you can't say, hey, look at all the key items that have this particular key pattern and do a sum on all of them, anything like that. Dynamo is going to limit what you can do. You can basically look within a particular partition and item collection, and you can get 1 meg of data at a time. So if you're talking about, I need to pull out 2 gigs of data and do like show some spark lines or something like that over the last year to show all that stuff, that could be sort of inefficient with Dynamo. So it depends on your use cases there. Some time series places, or like time series specific databases, might be better if you're doing sort of large scale aggregation where they're going to lay those out more columnar and can quickly do aggregations, things like that. So it depends on your use cases, but yeah, generally it can. There are some blog posts out there. I think Alex Casalboni has a really good one from a couple of years ago around that, but it depends on your use case. Jonathan, friends don't let friends do scans. I love it. Thanks. Okay, Hussam has a question. You want to turn on your mic and ask that one?
Yes, thanks, Alex. So basically, starting up this new startup project, which is also IoT based. And so in the long term, I'm going to have thousands of objects matched also with users, and these objects basically have screens, so the user can decide what content they put. And so the issue is that so far I know how my data is structured, but I have absolutely no idea about how my queries are going to be, because the project is so early on that I don't even know how my users are going to use my front end to update the data. So what happens is that I need some flexibility, and I need to be able to change my queries, because I expect my project to evolve very fast in the coming month, because everything is still new and it might evolve very much from an alpha, from a beta to something ready. And so the issue that I see here with DynamoDB is that it's really great because it allows you to access your object with the same speed from the beginning, whether it's 300 kilobytes to 10 terabytes. So that's very good. But then the issue is that you really need to know how you're going to access your data. And so I see a bit of a conflict here between the fact that I'm setting up a new project and that I should go for DynamoDB because it's IoT, so it's thousands of objects. So I need something that can scale up very easily. So what would you recommend here as a solution?
Yep, good question. And Amy, the next question is sort of right along these lines, right? You need to know your access patterns beforehand. What happens as these patterns change? You need to patch the data. What's the best approach? So I'll take it at a general level, and then I'll come back to you, like your specific situation. So in general, I think it's true that like migrations feel more difficult than in other places, but it's also like a fairly straightforward pattern. I actually talk about this in the book too. Like if you're adding new items into your database, like you actually don't need to remodel anything, because now you're just writing new items. You just need to plan out what that looks like, and there you go. The tricky part is that, like, if you have existing items in your database that you need to access in a new way, and that pattern usually involves just basically you run a background scan on your database. You look for the types of items you need to update. So maybe you have 5 items in your database, but you only need to update users or something like that. So you do a scan, you say, is this a user? If you find a user item, you in that scan sort of processing, you do an update that says, hey, add this new GSI1 PK, GSI1 SK values based on the existing values, something like that. And then you go along. Now you have your new secondary index and you can add it that way. And it's a very formulaic thing, right? Where you scan, identify it's the right one, run an update if so, and it's formulaic. You can set up some scaffolding around this, and there's actually a little bit of tooling out there that'll help you with this too, to where it's not as bad as it used to be. It feels kind of tricky, but once you do 1 or 2 or 3, you're really in pretty good shape there. So I would say that at a general level, like adding those is not as hard as people think. Now, in your more specific level, where you're so early on and it could be changing quite a bit, you could be frustrated with some of that stuff. And you know, again, like databases are about trade-offs, and think about what sort of compute technology you want to use, but also how quickly it's going to be changing, things like that. You know, if you want to use something like a relational database or something to get started, you can do that. But just sort of think about the trade-offs and think, hey, at some point, am I going to want to make that move? Or, you know, right now, you know, maybe I don't know every access pattern am I going to have, but if I know the big 2 or 3 or something like that, I can get that, and I can evolve over time. You know, you're evaluating trade-offs. There's no sort of one right answer there, but I think it's doable. It just depends on your sort of appetite for different things like that.
Okay, thanks.
Cool. Daniel, link to best practices for time series data. Thanks for doing that. That's a great post there. Jonathan, oh yeah, I mean, saying we talk about sort of migrations in the book, so yeah, check that out. Angelo, how do we validate that our data model will scale well? We know our access patterns and production uses by partition, so we'll model our load tests based on those. We plan to use DynamoDB contributor insights to monitor for hot partition. Is this sufficient, and any other recommendations? Yeah, the nice thing about Dynamo is like it's pretty straightforward to understand where performance problems will pop up. And basically it's sort of 3 levels, right? Number 1, they constrain you from doing things that won't scale. So I talked about aggregations before. They're not going to let you do aggregations. Aggregations don't scale well. Also, they're not going to let you query easily off you know, just any free form attribute, and they're going to make it hard to do that. So That's number one. They won't let you do some of those things. Number two, there are a few ways you could sneak in bad access patterns that won't scale, but they're sort of easy to look for. Number one, like, do I have a scan anywhere in my code base, right? And you can look for that on pull request reviews. You can search that on your database. And if you have a scan, I'm not saying never ever use scans, but almost never use scans, right? You should definitely know what you're doing, and figure it out that way and say, okay, the scan is the right use case there. But that performance, is going to scale linearly as your database gets bigger, right? Because you have to hit every item to do that. Another thing is, with that query operation, one thing they're going to do is limit you to 1 meg of data on a particular query and then just give you a pagination token to sort of come back and get more results. You can look through your code and say, hey, am I using that last evaluated key or whatever that pagination token is called? Am I using that anywhere? Search through your GitHub or your code base, whatever, look for that. And if you have that, understand like, okay, how many times could this paginate? How many items could I get there? Because that could slow down over time, right? As you get more items and now you have to go from, instead of just one page, now you have 15 pages to go through to handle a request, like that's going to get slower. But you can at least look at that, start to understand, is this going to be a problem for me? So that's number two, like what clues do I have to sort of find that? And then the third one is one you mentioned around hot partitions, right? So really the only major limit you need to think about with DynamoDB is the partition throughput limit, where for a particular partition that we talked about before, it's going to be you're going to be capped at 3,000 RCUs or 1,000 WCUs, right, per second per partition. So that's on a single partition, right? Not your entitled table, just a partition. And then that's per second. Are you doing 3,000 read units or 1,000 write units per second? So this is pretty high scale stuff. A lot of people never need to worry about that. But if that is going to be a factor for you, now you need to think about sharding and things like that. So that'd be the last thing to say that you can't really find just by looking at code, but you say, hey, am I ever going to be doing traffic that high where that's going to be a problem? And if so, now you need to have a strategy for that. Cool, Patrick. Yeah, I think Patrick, he just to summarize, Hussein was talking about, do I use Dynamo for my early stage thing or do I use something else, maybe relational that's a little flexible. Patrick says, he ended up going with RDS, then RDX proxy, and then VPCs, and now he has a headache. And that really is the thing. It's like, what hassle do you want to mess with, right? So using a relational database with Lambda, it can be tricky. You need to set up all this infrastructure. You need to have an RDS proxy probably. You need to have VPCs and the associated hassle with that. So it's just like you have this whole hassle, or you have the hassle of how do I migrate my access patterns with DynamoDB? And it just sort of depends on what you want to bite off. So that's the big thing. Wayne Greeley, are there any DBA operations patterns that you see new users of Dynamo not paying enough attention to? If you're talking about like strictly operations stuff, there's just not a lot to do with Dynamo. I think the biggest thing I see is so many people just set provision capacity and they set it way too high. Just be like, I don't know how to even think about this, so I'm going to set it to some number and then never look at it again. And it turns out their utilization is like 1%. It's like, if you just turn that to on demand, you'd save a ton of money and have the exact same amount of operations. So definitely like look at on demand. I think people see the top line number and do some math and are like, hey, that's 7 times more expensive than provision capacity. And it's like, that's if you get fully utilized provision capacity, which if you're getting fully utilized provision capacity, that's crazy because you don't even have any wiggle room, right? So you gotta have some buffer. And also your traffic's gonna ebb and flow during the day. And in reality, like a lot of people just set their provision capacity and never look at it again and just throw money down the drain. So on-demand stuff, I would say, get some basic alerts set up. And the alerts, again, would be around throttling are gonna be the big one. Also around transactions, right? If you're using transactions, which are a huge, awesome feature, make sure you're checking out transaction conflicts, just because that could indicate contention on specific items. And if you're seeing a lot of conflicts, you might need to rethink how you're using transactions. So those will be the big ones. I think that's it. Again, like looking at huge discrepancies in RCU versus WC usage. But other than that, I think those are the big ones. I think that's it for.
I think that's it.
Okay.
We are a little close to 70 minutes of session now.
Okay.
I have a quick question, Alex. So
Sure.
this Lambda has come with this provision capacity or even the memory allocation. Sometimes I've seen developers allocating a lot of memory than the actual usage, but anyway they pay AWS whatever configuration that they did when they're spinning up the Lambda. but what happens is the performance gets hit if I exactly set the memory allocation. If I'm using a 128 MB function, I'm setting a lambda for 128 MB. A function that used to execute at 400 milliseconds now is executing at 800 milliseconds. So I end up still paying the same cost to lambda. So is there any kind of the right queries and the issues here in DynamoDB similar to lambdas?
I don't think so with Lambda there, or not with Dynamo as you're going to see with Lambda. You're going to get the same. I like to say recently that Dynamo performance is more like binary rather than a spectrum. And it's basically like, can I satisfy this query or not, right? Do I have enough capacity so that I'm not getting throttled or not? And if the answer is I have enough, then it's basically going to give the same performance, other than a little bit with queries. If you have queries that are returning a lot of items that have to read a lot of items, that'll get a little slower at the top end. But other than that, Dynamo performance is pretty binary, I would say. And then with Lambda, yeah, you know, that RAM associated with it, that RAM, provisioned RAM is also associated with CPU time. So make sure you're looking there. And, you know, especially if you're making network requests and especially signed network requests, like all the AWS ones, that's going to, you know, more CPU will help you there in a lot of cases.
Exactly. Yeah. All right, great. Wonderful. I think we had a fantastic session today. I think people are thanking us, Glenn and Manish on the chat are thanking for the session today. Many thanks to you for joining us today. And it's been close to 75 minutes of discussions, and it's fantastic. Probably I'll take a couple of days to process the recording, and I'll make it available for everyone online to go through in the future for quick reference, and anything else in the future. We'll see if there is another session that we can do for DynamoDB with much complex topic or anything else that comes up interesting in the days to come.
Awesome. Yeah. Thank you. Thanks for having me. This was a lot of fun.
Great.
Yeah.
Nice. Nice meeting you, Alex, by the way. Thanks. Take care. Thanks a lot, people. Thanks for joining today. Take care.
Thank you, Alex. Thank you, Prasanna. Bye.
Bye-bye.
Thanks, Prasanna. Bye.
Thanks a lot.
Thanks a lot.
Thank you.